I'm back, having found some triethylamine in my research lab. So what I want to do, using a clean pipette, is add about 5 drops of triethylamine. Or 6 drops. So that the amine stays in the free base form. I'm going to go ahead and put this triethylamine back so that I don't forget. When you're running thin layer chromatography, you'll need a pencil because you need to write on the plate with a pencil. The ink from your pen will actually run up and separate and give you additional compounds where you don't want them. So I'm going to grab a pencil from my office, since the one that I left in the organic lab earlier has been stolen. So what we want to do is we want to mark the TLC plate far enough towards the edge so that when we put it in there, the spots will not be submerged. So, yeah, maybe about there. And then what I'm going to do is spot the standard and my crude isolate, and then in the middle I'm going to do what's called a co-spot, where I spot both the standard and the crude isolate on top of each other. And I'm going to do the same thing for each of those compounds. I'm going to be a little bit careful. So I'm going to label this vanillin up at top, and S for standard, and E for extract, and CO for co-spot. This one is going to be the tryptamine. And this one is going to be the cinnamic acid. So we've got our 3 plates ready. And we have our standards, and then our extracts. And I'm going to be using the round 2 extracts in each case. So the vanillin, the cinnamic acid, and the tryptamine from round 2. We won't worry about the first extraction, although we'd expect them to be somewhat similar. All of these compounds have significant pi bonds in them, which means that they should be able to absorb UV light. So one of the ways I can see how much compound I'm putting on the plate is by shining the UV light on it as I apply my spots. So I'll take one of these capillaries. These capillaries have been prepared by taking a pipette like this and drawing it out so that you get a much thinner capillary. You'll see that's significantly thinner even than the tip of the pipette. So what we want to do is get our vanillin standard, which is here, Landstedt, which I made up by dissolving about 20 milligrams of vanillin. It's not necessary to get very much sample in there, and I can reuse the spotter by just recognizing that the sample went up to about there. So I'll spot a little bit of that vanillin standard on there, just a quick tap. You see the dark spot where the vanillin is absorbing the light, and I'll just spot it again. That's a good size spot, nice darkness, and then I can break this off just above where the vanillin came. Oops, sorry. I forgot to put the co-spot, right? Because I want to spot them on top of each other. So put the vanillin and the co-spot there. And now I want to take my vanillin extract from round 2. And spot that on the extract, and then also on top of where it says co-spot. So if the compounds are different, I would expect to see 2 spots on the co-spot. So looks like a good concentration, and just a little bit on top in the co-spot as well. So you can see I've got nice dark spots on the baseline. They don't want to be too big, because then closely separated things will not separate nicely. So that looks pretty good. Vanillin plate is ready. And now I'm going to do the same for the cinnamic acid. Which I also made up by dissolving about 20 milligrams of cinnamic acid. So I'm going to spot that there for standard. You see the nice UV active spot. Spot a little bit in there for the co-spot. Take it off. Sometimes I just throw that on the floor rather than going for the glass waste. And then my standard cinnamic acid that I dissolved in ethyl acetate. Or my extract, rather. And I know from the GC mass spec that this actually has some vanillin in it as well. So I should actually be seeing that in the TLC. Again, put it both standard and co-spot, nice spots. So the cinnamic acid plate is ready to go. And then the tryptamine plate. And in this case, the standard tryptamine wouldn't dissolve in ethyl acetate, so I added about 1 milliliter of ethyl acetate to my 20 milligrams of tryptamine, and then I added maybe 0.3 milliliters of ethanol, which is what it's more soluble in, to get it to dissolve. So I'm going to spot the standard and the co-spot, and in this case I have to wait a little bit longer. Ethanol takes quite a bit longer to evaporate off the plate than does ethyl acetate, and I want to make sure that it's dry before I apply my second batch. Where you don't want these spotters is in the sink or on the bench, because then when you go to clean up at the end of the day, you're likely to wipe down with a sponge and spear yourself with the capillary, and that's painful. So now we're going to take our tryptamine in ethanol, and since this is purely in ethanol and not ethyl acetate, I'm going to want to be very careful to put just a small spot and let it evaporate completely before I apply a little bit more. And then I need to make really sure that the ethanol evaporates before I put it in the chamber, because ethanol is very polar, and if I have too much ethanol in there, it will cause the RFs to be falsely high. So we have our 3 plates ready. And now we can put these in the chamber and let them develop. We want to let them develop till they're close to the top, probably about as far from the top as the initial thing is from the bottom, or just under where I wrote vanillin. When you put that in, you want to try to make sure it doesn't touch the sides, because then it can develop crooked. But one of the reasons we do the co-spot is so that if it does develop a little bit crooked, we're still okay, because we can see if it's different that there'll be 2 spots in the co-spot, 2 different locations. So we have 3 different solvent mixtures. We have a 3-to-1 mixture of petroleum ether to ethyl acetate for our vanillin. We have a 7-to-1 mixture for our cinnamic acid, and we have a 1-to-1 mixture with our tryptamine that has a little bit of triethylamine in there. And that may still not be polar enough. sometimes you have to go to a more polar solvent mixture, which is often a mixture of methanol and dichloromethane, 5% or 10% methanol in remainder dichloromethane. As an aside, while we're waiting for that TLC, you can see that our attempted recrystallization of the tryptamine is still yielding no product, so it may be necessary to let that completely evaporate and start over with a different solvent mixture. I'm just going to take the beaker away and let that evaporate in the hood some. So the vanillin extract and the Cinnamic Acid extract will also need to be purified, and we can choose to do that by recrystallization, because there are suitable recrystallization solvents in the literature for both of those, or we can choose to do it by column chromatography. And I'm going to do the vanillin by column chromatography and the Cinnamic Acid by recrystallization, but you could choose to do the opposite if you wanted to. And we know that the literature has reported that a good mixture for doing column chromatography with vanillin is an 8:2 mixture of petroleum ether to ethyl acetate. So we already know what we're going to run that in, which is very nice. It's nice when they tell you that. So that's a 4:1 mixture, right? Or sorry, it was a 10:2 mixture. So that's a 5:1 mixture of ethyl acetate to petroleum ether. So I'll need to make up some solvent for use for column chromatography. But for now, let's focus on the thin layer chromatography results. (10 to 20 milligrams per milliliter is a good concentration for TLC for most compounds. So I'm going to open that up and take a look. Yeah, that looks like a good solvent front. So I'm going to mark the solvent front so I know how far the solvent went. And let the solvent evaporate, the eluent. It's important to mark it promptly because as it evaporates you won't be able to tell where the solvent front was anymore. That one hasn't gone far enough yet. So we can let this evaporate until it doesn't smell like solvent anymore. And what we're going to be doing is measuring the RF value, or ratio to the front, by measuring in millimeters how far the spot moves and dividing it by the total distance between the starting point and the solvent front. Your RF value is always between 0, which is not moving at all, and 1, which is moving all the way to the top with the solvent front. Ideally, we'd like an RF value somewhere between 0.3 and 0.7 if we've chosen a good solvent mixture, which allows us to see impurities that are either more polar or less polar. More polar compounds will stick and attach themselves to the silica gel, which is a hydrogen bonding surface. It's SiO2, but at the surface there are hydroxyl groups, so it can act as both a hydrogen bond donor and a hydrogen bond acceptor. So if you look at the structure of vanillin, you'll see that it has 3 oxygens in it, a hydroxyl group, a methyl ether, and an aldehyde. So there are 3 oxygens that can act as hydrogen bond acceptors, and then it also has the hydroxyl group. So there's that one hydrogen can be a hydrogen bond donor. Cinnamic acid, if you look at the structure, has 2 oxygens in it, carboxylic acid oxygen, and 1 hydrogen attached to an oxygen. So cinnamic acid has 2 hydrogen bond acceptors, and it has 1 hydrogen bond donor. And then if you look at tryptamine, it has 2 nitrogens with lone pairs on them, so 2 hydrogen bond acceptors, and it also has 2 hydrogens attached to nitrogen, so there are 2 hydrogen bond donors, which makes it significantly more likely to bind to the silica gel. And as an aside, we're still getting no crystals. So we're going to have to try a different solvent system. That hexane ethanol system did not work. I'm going to turn off the hood light so we can look at these under UV and circle the spots that appear. So you can see that the vanillin, there's a spot up here and another spot here. That's the co-spot, so that's probably our vanillin, and our extract looks like it has that in it. But then there's another spot here, which is presumably the trans-cinnamic acid. Carboxylic acids often stick fairly tightly to the silica, so even though vanillin has more total hydrogen bond donors and acceptors, it's not that surprising that it's moving less quickly, or sorry, more quickly. In our cinnamic acid, that was not a good solvent system for this, right? Because we're not getting separation. Right, our RFs are too low. So clearly, the result from the literature, we could use a more polar system for both of these and get better results. And for the tryptamine, yeah, nothing doing, right? It's sitting on the baseline. That's not really surprising. It's often necessary to go to a more polar solvent for amines. So this solvent system was ineffective, the 7-to-1 mixture, which I made more of, so I definitely don't need that. And even the 3-to-1 solvent mixture was not really good enough.